Hell yeah, point slope form, and I didn't catch this error in the video. Obviously, you're just using 1 point, a y1, x1, so I just changed these to a 1 and enjoy the video. Alright, hell yeah. So the point slope form of an equation. No one writes it like this, but hell yeah. If you do, it might make a little bit more sense, and you might be able to intuit it right off the bat. So we have y is equal to mx plus b. You know what I mean? So that's the y-intercept form of a line. And so hell yeah. So how it's typically written is you get the y1 to the other side, and then hey, these both have m in them, so we can factor out that term, and then you have x minus x2. So that's where it comes from. Alright, hell yeah. So let's break this one down, and we're going to start with the y-intercept form. So we have y is equal to mx plus b. Now I'm going to do it from like one equation and how many unknowns standpoint. Now for point slope form, we're assuming that we know the slope. You know what I mean? And so we're going to say in this equation we only have 3 unknowns. We don't know what y is, x is, and b is. So then let's start making our other equations. And this might not be super obvious, but if you do it this way, you're like, oh yeah, no duh. So I'm going to say x is going to be a value x1. Cool. And this could be any number, right? Because, you know what I mean? If you have an equation for a line, you can throw in any value for x, or you could do it in reverse and throw in any value for y. Alright, so this is our second equation. And then I'm going to say y is equal to y1. And that's our third equation. And so sure, these are a point x1 and y1 are a point on this line. You know what I mean? In the form x, y. And you know what I mean? Where x, y could be any point, we've just chosen one. Okay, sweet. Alright, so now from the idea that we have 3 equations and how many unknowns do we have? You know, and we're just saying m is known. M is just a number. It's not going to be unknown for this. So we have 1 equation, 3 unknowns. We have 2 equations, you know, 1 unknown, and the third equation, 1 unknown. So there you go. We have 3 equations, and x, y, and b are our unknowns, where we're saying this point y, x1 and y1, we know it, and we're good there, and we know the slope. Okay, hell yeah. So now that we have 3 equations, 3 unknowns, we can just put them together. Typically what you'd want to do is take the equations with all of, you know what I mean, we're going to throw this value in for x, this value in for y, and then we can solve for b. You know what I mean? And you can do that in any steps you want. You could just take this equation and solve for b right away. So you could say b is y minus mx, and then just put in these equations. So that's going to be y1 minus m x1. Cool, so this is what b is, you know what I mean? And so once we now know what b is, and b is just a number, you know what I mean, these were inputs and our slope was an input, we can throw it back into this original equation where we have y is equal to mx plus, and now we have y1 minus mx1. Cool. And then the point slope form, they just take what we got right here. Bummer. Yeah, this doesn't have to be this. Sorry, this should be a 1. We're not taking 2 points. That kind of messed up my whole video. But whatever. Okay, so hell yeah. So then we can take this and just rearrange it. We're going to get this over here, so we're going to have y minus y1 is equal to, and then, you know, I mean, I'll do this in a couple steps. So we have mx minus mx1. Cool. So now we're going to go y minus y1, and we're going to factor this m out. So we're going to have m, and then what we're left with is x minus x1. And sweet. Alright, and so that is the point, what is this? Point slope. So we know a point, x1, y1, and the slope, and this is the form that we're going to use it in. Bummer. So I kind of messed up my whole video. We'll see if we redo this one. Might as well. But now we're going to do one useful use for the point slope form, and then you compare it. You know what I mean? Because all we did, point slope is just like, if you could remember it, but how the hell are you going to remember that without first double checking that it's solving for b? getting that component for b and then shoving it back into this equation. You know what I mean? Using 1 point to solve for b and then throwing b back into this equation, and then, you know what I mean? I just don't see how else you're going to remember this point slope form. Alright, hell yeah. So I typed this into Google and I asked, hey, when is point slope form useful? And they said, well, it's really useful because typically you'll know a slope, but you won't know the equation for a line. And you'll know 1 point on that line. So sweet. So we have a equilateral triangle. It's offset in this first quadrant of an xy coordinate. Cool. And all these angles are 60, so that's cool. And what we're going to have is, and this is 1, this is 2. So we know this point right there, it's going to be in the x direction, we're 2. In the y direction, we're 0. So hell yeah. And just always, if you get a point, always double check it, because it's real easy to flip those numbers around. And so x, y, it's kind of how we do it. And booyah. And do I know this slope? Sure, a 60 degree, let's say if this is a right triangle, and I have 60 degrees here, 30 degrees here, and I'm just going to throw a value of 1 on here. If this is 1, this is going to be 0.5 or half, and then this is going to be 0.866. I typically like to work with the decimals first because you can see that, hey, this line is 50% of the hypotenuse, and then you can do a little double check. You know what I mean? Divvy it up into halves, and you're like, hell yeah, that line's 50%. Sweet. And then this is going to be 86.6%. That's how you can read that. Or it's going to be a ratio of 0.866. So does that make sense? If this is 1, what? That looks like about 0.866. And hell yeah, these lines are about the same. So that's a good way to do it. The other thing to know is that this, if you double this, you know what I mean, which is a good mathematical thing just to be able to do, to be like, hey, this is 1.6, this doubled is 12, this doubled is 12, and that's how you could write it. So we would have 2, 3, 7, 1, and 1.732. And both these, there's a 0 here. So even here, I think there's like a 1, but I mean, this is really accurate, and this should scream square root 3. So, you know what I mean? Know your square root 3 as a decimal, and then know that this is half of square root 3. So this length here is square root 3 divided by 2. This length is 1/2 as fractions. And this is my rise, this is my run. So now I know slope. So the slope of this is going to have, and it's a negative, you know what I mean? So if I'm actually going down, so we got square root 3, 2, and this is 1/2. So my slope is down square root 3 divided by 2. And then my run is 1/2. Okay, hell yeah. So dividing by a fraction is multiplying by the inverse. And so I can multiply by 2 divided by 1. So hell yeah. So right here my slope is negative square root 3, which is negative 1.732. Always good to write out because like you're like, hell yeah. If this is 1, you know what I mean? Like, hey, this is 1. And does that make sense? I go over 1, but you know what I mean? It looks like I'm going down more than 1, and I'm going down 1.732. So hell yeah, we got a slope that's steeper than 1. It's almost a slope of -2. Okay, sweet. So now that we know our slope, now we're going to see how easy it is to get to this y-intercept form. I'm just going to say y is equal to mx plus b. This is the slope of a line. I know 1 point, you know what I mean? So I know x is 2 when y is 0. So here's 1 equation, 2 equations, 3 equations, x, and I know what m is, you know what I mean? So this is negative 1.732. And you could even say this is a 4th equation, and I have 1, 2, 3, 4 unknowns. So yeah, so you know, I said this, if you knew slope had 3 unknowns, but we should consider the slope an unknown. So this is 1 equation with 1, 2, 3, 4 unknowns. And here's 1 equation, 2 equations, 3 equations, 4 equations. Okay, sweet. So it seems like we have too much going on. No, I guess that's just how it works out. Sometimes it's just bizarre when you see it so simplified. You know, I have 1 equation with 4 unknowns, and then I have 3 other equations that this is equal to a number, that's equal to a number, and that's equal to a number. So this does say we know everything, we can solve for this, we can solve for everything about this. So hell yeah, so let's do that. So we're going to throw in 0 for y, we're going to throw in the slope of negative square root 3, x is 2, and then plus b. So what makes this 0? We can get this to the other side, so we can say b is negative 2 square root 3. Hell yeah. So now that we have b, we can go back to our equation and be like, hey, this is the equation of this line. It's y is equal to, the slope is negative square root 3, x minus 2 square root 3. And does that make sense? I don't even think so. See, I even caught my error, because back here is just like, hell yeah. This is what happens a lot, is like, hey, you have this line, and maybe you know the slope. You know what I mean? So we know the slope is negative square root 3. But I have no idea where it hits the y-intercept. You know what I mean? If I did, I'd be like, hell yeah, the equation for this line is y is equal to mx plus b. I just don't know what b is. I have no idea. But I do know what the slope is. And so this is where you take 1 point and throw it into this equation and solve for b. I just made a big hiccup here, and it's just like, no, b is positive. If I throw a... if I isolate b, get this to the other side, it's positive 2 square root 3. So hell yeah, so that's b. And that's where it's going to hit. So what do we say square root 3 is? 1.7. So 2 times that is going to be 3.4. So hell yeah. So it's going to come up here to a value of b about 3.4, which is 2 square root 3. Hell yeah. And booyah. Alright, so hell yeah. So, but if you knew the equation for point slope, what is it? It's y minus y1 is equal to x minus x1. Now, if I used it yesterday, I'd be able to, come up with this today. But if I waited more than a month, hell no. I'd have to go right back to y is equal to mx plus b, solve for b. And so, you know what I mean? So it is kind of cool. I could write this as y is equal to mx. And then what's b? Well, b is if I got this mx to the other side. So I can say b is plus y1 minus mx1. You know what I mean? So I can just do that in my head. And should we do that again? You know what I mean? If I have y is equal to mx plus b, and how I solve for b is I have to throw a y1, mx1, and then I can solve for b. And solving for b requires taking this to the other side. y1 minus mx1 is b. So if I can just do that in one step and say that b is y1 minus b is y1 minus mx1. I can just write this, I can just now go right to the point slope form. I can say y is equal to mx plus y1 minus mx1. And that was the whole point of this video. And sorry for the error right at the beginning. There's not two, but it's the point slope form. You just need 1 point. Sorry for calling that a 2. So it's x1, y1. And that's the equation we get. We get y, mx plus, what's b? Well, I would have put a point in here, y1, x1. Get this to hell to the other side. And then we get that y1 minus mx1. And then it's just algebraic manipulation to rearrange this equation however you want. Y minus y1 is equal to mx minus x1. All right, so back to our little equation, and we're going to see if we could have got there all in one step. So we're going to say y minus, here's my point, is going to be 0, is equal to m, the slope is negative square root 3. And then we're going to have x minus 2. You know what I mean? And then you still got to do the algebraic manipulation to make this look like a normal equation. So we're going to go y is equal to negative square root 3x. And then, you know what I mean? Don't forget to FOIL this in. And we have a negative square root 3x. And then we have a negative times a negative. So that's going to be a positive plus 2 square root 3. And hell yeah, that's our answer. And so I'm pretty satisfied with the length of this video and trying a problem and just going for it, you know what I mean? It's good to be able to just go for it. So, hell yeah. And right at the beginning, I'll try to say my mistake right there, but I don't want to do this video again. So sweet. So we use point slope form, and this does come up quite a bit. You know what I mean? And you're just like, well, how the hell do I get the equation for the line? Well, you throw in a point, you know what I mean, and solve for b. So the point slope form, again, it just speeds up that process. This equation would be y is equal to m, know the slope, x, plus b. What would b be? Well, I would have solved for it anyway, so it's going to be y1 minus mx1. And hell yeah. And I think this is pretty good, that if equations were in the form like this, you would better be able to see, you know what I mean, where they came from. That's why I like to change up quadratic equation. I think quadratic equation is the worst. You take something, get an answer, and then you try to simplify it to get it into a form that looks nothing like how you solve for it in the beginning. So, booyah. This is y is equal to mx, and this is the b part. You throw in a value for y1, throw in a value for y2, and to solve for b, you would have had to get that negative mx to there, and you would have y1 minus mx1. Alright, hell yeah. Thanks for joining me, and booyah.